An aging aircraft isn't defined by how old it looks. It's defined by how long it has been in service and how many flight hours and cycles it has accumulated. Even a well-maintained aircraft experiences gradual structural degradation over time as materials respond to repeated loads and environmental exposure. Aging aircraft management focuses on understanding how structures change with use and ensuring safety margins are maintained throughout the aircraft's life. As aircraft age, structural challenges become more complex and less predictable. Small manufacturing variations, repairs, and modifications can interact over time, creating new stress paths or hidden weak points. Older aircraft may also have outdated designs that were certified using earlier assumptions, so engineers must reassess structural behavior using modern knowledge and inspection techniques to ensure continued safety. Fatigue and corrosion don't happen overnight. They build slowly, flight after flight, year after year. Fatigue cracks grow with repeated pressurization and maneuver loads, while corrosion weakens structure where moisture and contaminants collect. Over time, these mechanisms can interact, accelerating damage and reducing structural margins if not detected and controlled early through inspections and maintenance programs. To manage long-term safety, aviation authorities and manufacturers use structured aging aircraft programs that track damage trends, inspection findings, and fleet data. These programs define targeted inspections, revised intervals, and special checks for known problem areas. The goal is proactive monitoring, catching issues early across the fleet before they turn into safety concerns. Life extension measures help aircraft safely operate beyond their original design expectations. These can include structural reinforcements, corrosion-resistant materials, improved coatings, redesigned joints, and updated inspection techniques. Modifications are carefully engineered and certified so aging aircraft can continue flying safely while meeting modern safety standards and operational demands. One of the biggest strengths of aviation safety is learning from real-world fleet experience. Inspection results, repair histories, and in-service findings are shared across operators, manufacturers, and regulators to identify patterns and emerging risks. These lessons feed back into design improvements, maintenance programs, and future aircraft development, turning operational experience into safer skies. That brings us to the end of Module 5. In this slide, you will find some of the references used in preparing the content and some additional links and references for further reading.